All right, so today we're going to start Unit 5 on balancing and types of reactions. What we need to first learn are what a chemical reaction is, what it looks like, what symbols are used. We have talked about reactions before in previous unit. However, we focused on nuclear reactions. So today we're going to talk about chemical reactions and what it entails. So chemical reactions, you can take out your comp book right now and make sure that you're writing these notes in your comp book, labeling it Unit 5. All right, I'm going to start inking here. I have some of it typed up, and I will include some inking as well. All right, chemical reactions. There are various indications that a chemical reaction has occurred. These are some visuals that if you're in a lab, you can identify that a chemical reaction versus a physical reaction has occurred. For example, a color has changed. So when you're adding two chemicals together and an outcome of a color change occurs, if there's some sort of solid that forms as a result. And when you look at a solid within a solution, it kind of looks gel-like. It doesn't actually look like a solid until you remove the solution in the product. Then if you were to dry it, it would actually be a solid, so it is considered a solid. There is a special name for the solid that's formed. It's called a precipitate. And its shorthand is PPT. We're going to talk a lot about precipitates when we talk about a type of reaction called a double replacement reaction. All right, another thing that we can observe is maybe bubbles formed, or if there's some sort of heat. And it's not always heat in the form of fire. It could also, which is produced, it also could be absorbed. So you could feel, maybe if you had the reaction in a test tube and the reaction occurred, you could feel that test tube getting warmer. And that those are all indications of a chemical reaction occurring. A chemical reaction is represented by a chemical equation. So the left side of the equation, I'll pull it down a little bit. The left side of the equation, there's a vocab word called the reactants. They react together, or they may only have one reactant. And then you have the product side is what is produced. Notice that we only have a one-way arrow here. So I have the reactants making a products. This isn't always the case. There is something called an equilibrium, and I'm going to kind of show you that. And we're going to actually focus second semester on an entire unit on equilibrium reactions. This chemical equation shows that the reactants are on the left and the products on the right, which is the convention way of the chemical reaction. The arrows mean reacts or produces, so that is what that means right here. This arrow makes, to react, to produce, all of that means the same. It also shows that this reaction does not go the opposite way. Okay, it's irreversible. You've got one way. However, if the arrows show above were replaced with the double-sided arrow, like such, it means the reaction is reversible. This is known as an equilibrium reaction, and we will talk about that in second semester. Other symbols that you're going to encounter, there's a little s is solid, a little L is liquid, a little G in parentheses means gas, and the word aqueous is AQ in parentheses. It means dissolved in water. And then the symbol, delta, means heat is added to the reaction. Okay, so these are all symbols you are going to use and encounter throughout the rest of the year. The physical states in parentheses sit next to each reactant or product and heat when used in a reaction. So it's really used in a reaction, it sits on top of the arrow. So this is where heat is. So it's in the reaction. This is why that symbol heat is right there. So here's an example. I wrote the example in words right underneath the example that's written in symbols. Last unit focused on, can I write the formula and do I know the name? Okay, so we need to keep practicing Unit 4 throughout the rest of the year. So this reaction says you have methane gas, which is CH4. You know it's a gas. I put a little G there. and you know it's two nonmetals put together, so it is a nonmetal molecule. It is heated in the presence of oxygen, which is O2. Oxygen is in gaseous form, so it's a gas, and it produces liquid water, so there's the L, with the H2O, and carbon dioxide. That's our molecule naming. Carbon dioxide gas, and this is why I have the symbol G. Okay, so this is an example of a chemical reaction. The numbers in front of the oxygen and carbon dioxide are called coefficients. And it's the coefficients that balance the equation. And this is our focus today's lesson, is balancing the equation. Balancing the equation occurs because of a law that we learned in physics class last year. You cannot create or destroy atoms. Can't create them or destroy them. So if you notice, I'm going to get a quick glimpse of what this entails, is that if you have one carbon on the reactant side, you should have one carbon on the product side. Not necessarily because in the same form, because you are undergoing a chemical reaction, and so they can't be reversed. However, you need to include how many you have. So if you're looking at hydrogen, here you have 4. If you're looking at hydrogen here, originally you had 2. So that is where balancing and putting it in front of the molecule or ionic compound, the coefficient, to make sure it balances. However, what happens here is when you put a value in front, it gets distributed to both of the atoms. So you now have 4 atoms of hydrogen on the product side, and you have 2 oxygen. So in this case, you have an addition. So when you're looking at oxygen, you have 2 from here, and now you have 2 from here. 2 plus 2 means that you have 4 oxygen atoms. So originally you only had O2, but when you distribute and you place a 2 in front of there, it gives you 4 oxygen. So now you are looking at a balanced equation. So the red ink is including what you had to change. The only numbers you're allowed to change is the coefficient, the big number in front of an ionic compound or an atom or a molecule. You are never allowed to change a subscript, because if you change a subscript, you'll be changing the actual molecule or ionic compound. Okay? This again has everything to do with the law of conservation of mass. Remember, if I'm going too quickly with my notes right now, you can pause, write the notes down in your notes, in your comp book, and then continue. The law of conservation of mass says that in a chemical reaction, atoms are neither created nor destroyed. This means that atoms count must not vary between reactants and the products, which I've shown above. The 2 added on the front of the oxygen gas and water ensure that you have the same number of each atom existing both on the reactant side and product side. So here are some rules that I want you to write down to be successful in our balancing equations. The formulas, in other words, the subscripts, never, ever, never, ever, 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 ever can be changed. Those subscripts, for example, the one I pointed out above in methane gas, you cannot change that little number. You can only place a value here in the coefficient area. So the first rule, make sure that the unbalanced equation is correct. You need to make sure that you wrote the formulas correctly. So when I stress the importance of Unit 4, this is where I'm stressing it again. If you had any difficulties, you must keep practicing Unit 4 on writing the formulas and writing the names. Number 2, start balancing using the most complicated molecule. The one that looks more complicated would be the one that you'd want to start with. The third, balance one element at a time, going back to double check all the elements. Kind of like how I just showed you in that very quick example above. And number 4, check to ensure that the coefficients are the smallest integers that will give a balanced equation. What that means is that if you have coefficients that are 2, 4, I'm just putting coefficients and no values here, and you have 4 and an 8, you can actually divide out and have 1, which you wouldn't write in front of a coefficient. This would be a 2, and this would be a 2, and this would be a 4. That is the lowest or smallest that you can go. All right, so this video just went over the details and directions and rules for balancing equations. And I will make another video clip of just practicing the balancing that we did in class today.